Hello friends, welcome to Dr. Acharya Academy. Today we will discuss the topic stoichiometry and stoichiometric calculations. It is taken from the chemistry class 11 CBSE syllabus. Now, do not subscribe the Dr. Acharya Academy. Please subscribe it to continue with this class. Today's class ID 009. Stoichiometry deals with the calculation of mass, sometimes volume also, of the reactant and the products involved in a chemical reaction. For calculations, the amounts of the reactants required or the product produced in a chemical reaction. Any one you need for the calculation, either the amounts of the reactants or the amount of the products in a chemical reaction. Let us understand that what information is available from a balanced chemical equation. We'll give one example. Let us consider the conversion of methane. A balanced equation for this reaction is CH4 plus 2O2 will produce the CO2 and 2H2O. That means CH4 in its gaseous form, that's why in first bracket small g is there, and for oxygen also small g is there to mention it is in gaseous form, and for carbon dioxide also it is in gas, so g is mentioned here in first bracket, and here H2O in vapor state, that means gaseous state. Here also small g in first bracket is mentioned. We have to remember when we will give one equation, chemical equation, then its reactants and products state also you have to mention. Either gas or liquid. For liquid you have to mention small l, and if it is solid then you have to mention small s in the first bracket. Here methane and this dioxygen O2 are called the reactant. When compound is there, then it is called the reactants. And from the right side, both that carbon dioxide and H2O, it is called the product. The reactants, that means this part, and the products in this part are gases in the above reaction. And what I already told that G in first bracket you have to mention after the formula of each compound. Now you can see the coefficient. Coefficient for O2 it is the 1, and for the H2O the coefficient is 2. But for the methane, CH4, the coefficient is the 1. And for CO2 also, coefficient is 1. So here in this equation, for the CH4, the coefficient is 1. For O2, coefficient is 2. And for the product CO2, coefficient is 1. And for H2O, coefficient is 2. And you can consider this coefficient as a number of molecules or also mole. So 1 mole of methane gas reacts with 2 moles of oxygen gas to give 1 mole of carbon dioxide gas and 2 moles of H2O, that means water in vapor state. So here again I am writing okay. So otherwise you consider molecule also in place of mole, then you have to write 1 molecule of the CH4 gas reacts with 2 molecules of the O2 gas to form the 1 molecule of the CO2 gas and 2 molecules of the H2O water vapor in gaseous state. Third, we know that 1 mole is under the same temperature and pressure, and under STP, standard temperature and pressure, its volume is the 22.7 liter. Any compound, its 1 mole contains 22.7 liter under STP, standard temperature and pressure condition. So in this case, 1 mole of CO2, so in respect of volume, you can write that 22.7 and 2 moles of O2. This volume is irrespective of the compound. So 2 moles means 2 multiplied by 22.7 liters. So it will be the 45.4 liter. And to give again 1 mole of carbon dioxide, so it is the 22.7 liter, and H2O 2 moles. So in this case, it will be double. That means 45.4 liter. So in this way, we can express also from the given reaction equation. Another way you can represent, because CH4, its molecular formula is, it is a 12 and it is the 4, so it is the 16. So 16 gram of CH4 gas reacts with the 2 into 32. That means O2 is 2 into 16. So it will be multiplied by 2. And it will give the product 44 gram of CO2. CO2 means, C means 12 plus 32. That means 44. And 2 moles of H2O. H2 means its molecular mass 2 plus 16 is equal to 18. So now we understood from the chemical equation, we can write in respect of mole, in respect of molecule, in respect of volume under standard temperature and pressure, and also with the molecular mass. Now from that relationship, you can convert whatever I told already. In this way, you can convert, and even you will get the density also, because you can get volume also under STP, standard temperature and pressure. You always have to mention that when you consider any volume. Now, limiting reagent. Many a time the reactions was carried out with the amounts of the reactants that are different from the amounts required by a balanced chemical reaction. We'll give one example. What is the example? Another example, that with nitrogen and with hydrogen, it will produce the ammonia gas under certain condition. And in this case, the 1 mole of nitrogen gas with 3 mole of hydrogen gas to produce 2 mole of NH3 gas. So in this case, if you thought that in the reaction you put the 2 moles, then what will happen? 1 mole will be consumed if 3 moles of hydrogen only present there. Then 1 moles of nitrogen will be excess. But here, if it is a 6 mole, then 2 moles will be considered to consume for the nitrogen to produce the 2 moles of NH3 gas. Another example, if you see that same thing, if you have some 3 moles H2, and then you have that 3 moles of N2. So 3 moles N2 means 1 mole N2 will be consumed, and out of 3 3 minus 1, 1 is consumed, so 2 mole will be the excess. And under this condition, this 3 mole of hydrogen will be the limiting reagent, because it will determine the how much, in this case the 2 mole of NH3 will be formed. So in this case the H2, this gas, this reactant with the limiting reagent. So we have to write in this way. In such situation, one reactant is in more amounts, in this case the nitrogen gas, than the amount required by the balanced reaction. And then the reactant which is present in the least amount, in this case the hydrogen gas, whatever I already told, get consumed after some times, and after that further reaction does not take place, because when in this case 3 mole already consumed, then further reaction will not happen. And whatever the amount of the other reactant, that means in this case the nitrogen 2 mole is excess, so it will not be used in this reaction. And then whatever I told, that hence the reactant which get consumed fast, that means the example the hydrogen gas in this case, then the limits the amount of the product formed, and is therefore is called the limiting reagent. So what is the limiting reagent? Then we have to give one equation, and we have to give the exam, what is the condition for that, and what is the excess, and whatever reactant is totally consumed, that reactant is the limiting reagent. Now reactions in solution. A majority of reactions in the laboratories are carried out in solutions. Therefore, it is important to understand as how the amounts of the substance is expressed when it is present in solution. We already understood that mole is there. The concentration of a solution or the amount of the substance present in its given volume can be expressed in the following ways. How? Mass percent or weight percent, mole fraction, molarity and molality.